Hey everyone, welcome to this video all about using Terraform with Azure. And my goal for this video is to really kind of start from the ground up. So super quickly, kind of the whole imperative versus declarative and why we like declarative. A quick 101 about Terraform, exactly what it is, some of the key fundamentals about its installation. Understanding the importance of state when we use Terraform, and that'll make a lot more sense when we actually start going through a couple of demos. I want to talk about the structure of Terraform files, using the actual Azure provider for Terraform, creating resources in Azure through a Terraform script, how I can interact with Azure Key Vault. Now, Terraform has its own Vault technology, but I'm going to focus here on just interacting with secrets that I have in Azure Key Vault. And then probably don't need to do this, and we don't really want to do this very often. But if I do need to call an ARM template, which is Azure's native declarative technology, from Terraform. So super quick, the whole imperative versus declarative. Now, I have a whole video on this over on my YouTube channel. I go into huge amounts of detail about imperative and declarative and how I like to get to a pizza restaurant. So if you want the details of that, you can head over there. But the key point is that when I do imperative, I'm telling the system how to do something. Do this step, then do this step. Hey, check for if this is already there. This is how you handle this situation or this situation. I have to handle all of the errors, handle all of the possible current states of something, which actually gets super complex to do. It's also hard to compare what exists compared to some kind of declarative configuration. So if I'm using imperative, I'm saying do this, do this, do this, 100 different steps. It's very hard for me to look at those 100 steps, look at the current state, and work out, well, is that matching? Whereas with a declarative technology, it's actually super easy to detect drift, because with declarative, I just state what I want the desired end state to be. I'm saying, hey, I want a storage account. I want it to be locally redundant. I want it in this region. And I want a container in it called this. That's the end state that should be there. I'm not telling it how to create an account. I'm not telling it to create a container. It's its job to work out what's there today, what's the current reality, what am I being asked to do, and it has to work out. Either create the resources, maybe modify the resource if it's there, but it's the wrong type of resiliency, and everything in between. So essentially, with a declarative technology, it's the job of that technology to just make it so. We always think of kind of Star Trek and Picard, make it so. That's the job of a declarative technology. I'm just saying, I want it to look this way. Go do it. So it's much easier with a declarative technology to have a new desired end state. I could change my desired end state and just say, make this so. It's up to the technology to detect the differences. It's up to the technology to detect if there's any drift and kind of fix it. And when we think about Azure, it loves declarative. Fundamentally, Azure has all of its resources provisioned on the back end using some kind of declarative JSON technology. So even if I imperatively use the REST API, PowerShell, AZCLI, the portal, underneath everything, Azure is storing it as JSON. It's storing it as a state. So yes, I can absolutely use PowerShell and CLI. I can create things imperatively, but that's really not the ideal. I'm making a lot of work for myself to go and check, well, how do I handle this error? What if my script fails halfway through and something's already there? How do I now handle a change in desired configuration of the resource? I have to write all of that logic in my script. So resources are best provisioned using templates. Now, natively, Azure uses JSON-based ARM templates. Now, JSON is great for computers. It's really not great for humans to edit, to troubleshoot. It's also Azure specific. So if I was just using Azure, then maybe sure, I'm okay with using ARM. But if I'm using other clouds, if I'm using VMware on-prem, if I'm using other technologies, well, now I have to do a different syntax for every single one of those. With Terraform, I just have different providers, but I'm using the same syntax to use across them. Super quickly, this is an ARM template. This is JSON. You can see, hey, I've got some parameters that I'm passing in. I've got some resources that I'm going to create. I'm going to create a storage account. I'm going to create a container. But you can see there's a lot of code there just to create a storage account and just to create a container. It's also not super nice to read or even try and kind of create this from scratch. And yes, we are absolutely talking about infrastructure as code. We are defining our infrastructure resources using machine-readable definition files. These are prescriptive. I can put these in a source control system, a version control system like Get, and track this through. I can deploy this in a very prescriptive manner between test dev, between user acceptance to prod, without any risk of something being different. So this is really the foundation of doing things around infrastructure as code. So let's talk about Terraform. So it is a declarative technology created by HashiCorp. It uses Terraform text-based configuration files with a .tf file type. Now, because it is a text file, it's easily integrated with source control systems like Git. I can easily see what's changed between them. Now, there is also the ability to use JSON. I can use a .tf.json, but typically I'm going to stick to the .tf format, which is both machine and human readable. Terraform is written in Go, as are its plugins. You can use something else for the plugins, but I think 99.9% are all written in Go. And a plugin could be something like that provider to make it work with Azure, or with AWS, or Google Cloud, or VMware. Because it's written in Go, it's very easy to make this available across platforms. Now, what's interesting about Terraform is in this day and age, we're used to, hey, we install things, it puts files all over the machine, it does things to the registry. Terraform does not do that. If I go to the Terraform download page, here I can see, hey, look, there's macOS, Linux variants, Windows, 32 and 64-bit. If I was to download it, what I get is a zip file. And if I actually go and look in that zip file, it's terraform.exe. That is not an installation file. That is Terraform. So what you do is you take that file and you copy it somewhere. So in my case, I copied it to a C:/tools folder. There's my terraform.exe. From there, you simply add that to your path if it wasn't already. If I go to my advanced environment variables, my system path, you can see I added my tools folder. So now Terraform is just available to anything running on this system, and that's it. I don't do anything else. That is the installation of Terraform. As I mentioned, there are then plugins. So the plugins provide service-specific integrations. I already talked about a whole bunch of them, but there are many, many others. For example, Kubernetes. That would be a super popular one for many organizations. And there's a whole registry that I can go and look at. And Terraform themselves actually maintain a list of all the various providers. So here, if I look, I can see, hey, look, all of these have providers that are kind of official providers registered with HashiCorp. And what that actually means is if I use them, I don't have to manually install it first. When I go through the various Terraform phases, and I'll show this, but when I do an init, it will go and check, hey, look, what providers am I registering, what plugins, and it will actually go and pull them down and make them locally available. So it's super easy to leverage those, or I can manually go and install other providers. Additionally, Terraform is actually natively available in the Azure Cloud Shell. So if I just start up an Azure Cloud Shell, I can just type Terraform. It's there already, I don't have to do anything, which kind of gives you a hint of the close integration Terraform has with Azure. So before we actually go into details about the formats, let's talk super quickly about kind of what are the key phases. So we have to create Terraform configurations. Now, we create these in a workspace. A workspace is basically a folder. So I have a folder, and in there, I'm typically going to have 3 key files. I'm going to have a main.tf, which is actually my declarative configuration. I have a variables file, and I have an outputs file. We like to separate the variables from the main because, for example, I may set default values and I may have different values for different environments. I don't want to have to change the main.tf. I want to version control that and let that move between test dev and UAT and prod with no modification. Anything environment specific, I can put in the variables file. Now, there are other ways to override that. I can pass parameters. I can have an actual tf-vars file. I can set environment variables. There are other things I can do. But at a base level, I'm just going to separate out my main configuration, my variables, and my outputs. Here in my environment, we can see I've got a main.tf. Super simple bit of code here using the Azure RM provider version 2.11. I've got a little data section. I'm grabbing an existing resource, the resource group. And then I'm creating a storage account and creating a container. Note, this is doing the same thing that very large JSON template did. Gives you an idea that it's a lot easier to read and it's a lot shorter. I then have a variables file. Hey, look, I'm going to set the resiliency type. And I can also have an output file. If I jump over for a second, we can see the outputs. And there's my output. All I'm doing is outputting the storage account name. So outputs is super useful for conveying information maybe that I don't know before I actually deploy. For example, if I was creating a public IP address, I could return it here because I wouldn't know it until I actually made the deployment. So the first thing I do once I've got my configuration working is I'm going to initialize Terraform. So that's the Terraform init command. Now, this is going to basically take that workspace that's got all my files, and it's now going to pass through them, and it's going to kind of create an initial state, and it's going to look through my files and firstly look for, well, what plugins am I referencing? For example, I'm using the Azure plugin. It will automatically go and download those to a .terraform subfolder. I only run this once. I don't have to run this every time I have a slight change to my configuration. Now, if I added new providers, if there was a new version, I would run it again. I can even do a -upgrade to kind of force it to upgrade any even existing providers. But I'm typically running this once in my workspace, again, unless I kind of change that provider configuration. So what I'm going to do now is run that Terraform init. Now notice there's a Terraform fmt command. This will basically take my files, and if I had it poorly spaced out, etc., it would actually fix that for me. So it would fix all of the formatting for the files in my current folder. So if I ran that, it's actually showing me, hey, look, my outputs TF file, it fixed. It made some better formatting for me. So I'm going to run the Terraform init. Now, if I look currently at my folder, there is no .terraform subfolder. I have no states. This is the first time I'm actually running this. Additionally, if I actually go and look at where I'm going to deploy to, the resource group is currently completely empty. There is nothing in this resource group. So we're going to run the Terraform init command. So it's checking. And you can see it was looking, okay, looking for available plugins. Hey, look, the Azure RM plugin, HashiCorp Azure RM 2.11. If I now look at my file system, we can see I have a .terraform folder where it's put the Azure RM provider. So it's actually started to do that. So that's done that initialization, it's checking it, and we're kind of ready to proceed. So the next thing we want to do is the Terraform plan. Now this is going to create an execution plan, i.e. it's going to work out what actions it actually needs to perform to take the current reality, i.e. my current state, and make it match the desired configuration in my Terraform files. Now, this is not going to make any changes. This is going to show me what will be done, but won't actually do anything. So it's actually a good way to check, hey, what's going to happen? It's a good command to run, for example, before I'm going to go and check in my code into source control. Now, I can actually add a -out to my command, and I could then use that as part of an apply. Or when I run the apply, it will just go and kind of work it out again. So there's a potential of a difference, but it's pretty unlikely. Now remember, Terraform plan is comparing against the state file, if there is one. This is the first time I'm running it, I don't have one yet. But if the state file was wrong, i.e. I made a change outside of Terraform, it's going to skew what it thinks its actions required, i.e. its execution plan will not be correct. And I'm going to stress this later on, but we start to get an idea that once I use Terraform, I only use Terraform to provision things. I don't provision with Terraform, then go and create some other stuff, then modify things in the portal, then try and do something else in Terraform. It's not going to work as I expect. So I'm going to run the plan. So now it's going to go and look and say, hey, okay, what do I need to do? Okay, so it's actually complaining, hey, look, I've not actually logged in yet. So the first thing I have to do is actually log in with AZ. So I'm going to quickly do that. So I'll do my AZ login. Again, this is a new machine. I started everything fresh and blank so I could show you everything. So it's saying, hey, look, you don't have this installed. So I'll install the AZ. So here's the Azure CLI. So I can download and install this. That's installed. Now we can actually jump back. Now it's installed, I'll run the AZ login again. So it's going to make me pop up a browser and put in a code and we'll be good to go. So here we go. Yep, pick my account and I'm logged in. Okay, so now I have that AZ installed and I've done the login. Now no, I logged in, so I'm running this interactively as me. The other thing you can do is actually create a service principal and as part of the provider configuration, actually specify an identity to leverage. This would also be a managed identity. But if you actually look at the documentation for Terraform and Azure, it does walk through, hey, I could actually go and create a service principal. And I do show that up here in this file. And this is in my GitHub repository. So you could actually go and do the AZ add service principal, create for role-based access control, and scope it at a subscription or resource group, whatever you needed. And then that output, you can even add kind of an SDK offset, formats it nicely. I could use that as part of my Azure provider configuration. But for this, I'm just using my interactive account. So now, if I run plan, it's because there's no state, it's going to go and generate that. And then look at, well, what is my desired configuration in those files? And what I'll see is we'll actually create some files in my folder when I kind of proceed with this. Okay, so here we go. It's saying, we'll actually make this a little bit bigger quickly. All of these green things are things it's going to create. So it's going to create a storage account with these various parameters. And note, some of the things are known after apply. If they're things I cared about, I could have that as part of the outputs file, so it would actually show me. And also, it's going to go ahead and create the container I want. Now at this point, if we refresh, there's still no state file yet. That's going to happen when we actually go and do an apply. And at that point, we'll start tracking actually what's different. But it's telling us, hey, here's what I'm going to do. So the next phase is to actually kind of make that the reality. So I can actually run a Terraform apply, and it will now take that desired state and apply it onto my actual Azure subscription. It will prompt me for approval. I can skip that if I want with the kind of -auto-approve. So that's what I'm going to do here. I'm going to say -auto-approve. Remember, currently, if we go back to my resource group, it is empty. So let's go and hit that apply. So once again, because I didn't save the output of the plan, that execution plan, it's going to kind of go and work that out again. It's going to create that storage account, and it's going to create that container. So now I can see the storage account one is being created, and then I'll see the container created as well. And that's completed. So here we can kind of scroll up. So it finished creating the storage account, then it created the container. It added two things, changed nothing, destroyed nothing. And then the output was my storage account name, which is what I'd specified here. Hey, show me the storage account name. If I now look at my folder, well, now I have a TF state file. Now, yes, this is JSON, so that makes you think technically you could edit it. Let's say there's some state drift. Really don't. That's a far more advanced thing, and there's actually better ways to handle that anyway. Now, this is declarative. Now, if I go back to my resource group, so it takes a little while to catch up, often 30 seconds to a minute. So there's my storage account. If I go and look at it, I can see, hey, look, it's in that resource group, it's LRS. So let's just focus on that for a second. Now, I can look at the state file. Yes, it's kind of JSON. If we go over here, I could take that state file and I could say open with code, and we can see, hey, look, there's all the resources. So I can actually read it from here. But I can also do Terraform show. If I do that, it's actually going to go through that state file and show it in a little bit of a more friendly format. I can even list all of the resources it knows about in that state file and look at specific ones. So, hey, my storage account and my container. Now, what if, this is where declarative is super powerful. Actually, that storage account I created as LRS, I want it as GRS. Now, I could change the variables file, but in this case, I'm actually just going to pass it as a command line parameter. So I'm saying, hey, plan what you would do if the replication type was now GRS as part of that configuration. So it's going to look at the state file. Remember, it's not looking at what's deployed, it's looking at the state file, which is why it's really important that we kind of keep those things synchronized. We don't go and make changes outside of Terraform. But it's going to go and look, and if we go through, oh, there's an update in place, this yellow squiggly. Account replication type is going to go from LRS to GRS. And also it's saying it's going to remove a tag which I'm applying through policy. So again, I'm not applying that through Terraform, so it's going to remove it, but then it's going to go straight back again. So if I actually applied this now, what I'll actually see is that account will actually transform into GRS. I didn't have to write something to say, hey, if it currently exists, if it's not matching the type, then use this modify PowerShell command. It's saying I'd have to do with imperative. My desired state is just different. Go and make it so, Terraform. So I can see that is complete. So it has made that change. You can see it's modifying the storage account. So now if I actually go and look at this storage account, notice it's LRS currently. Now it is GRS. So it made that configuration change. There are some other kind of neat commands. I can visually look at the state using Terraform graph and output it to a dot file. And then that dot file I can actually read into a graphical visualization utility like GraphViz, and I've got the kind of link that you could actually go and get that. So that's kind of some nice things you can see. Now I mentioned the state. The Terraform core is responsible for a number of things. One of the most important ones is that state management. So Terraform stores the state of those managed resources in its state file. Now, it actually does create a backup. So what I should have now is a tfstate.backup file. So because I made that additional apply with the new type of resiliency, it backed up the old state for me. Now this provides that mapping of resource reality to my desired reality. So the configuration in the config files compared to what it believes is the reality. It's not scanning Azure every time I do a plan or apply. It's tracking it in that state file. So it's super important I really don't mess with it outside of there. Now those state files also track any kind of metadata that could be kind of Terraform specific. Now that terraform.tfstate should not be manually edited. Yes, I showed you it's JSON, and maybe more advanced people may be tempted to go and do that, but it's really not the right thing to do. Resources should be managed by Terraform, and I should not change things outside of that. So as a best practice, once I've started to engage in using Terraform, don't provision things outside of that. Don't change things outside of that. Now, one of the challenges could be if you're working as a team. I have 10 different people working on the resources. They all might be modifying the Terraform configuration and applying. Well, you need to ensure I'm using the latest version of the state file. Now, what this means is a number of different things. Either I take that state file and I make sure maybe it's checked in and other people check it out. But sometimes I don't want to do that. Maybe there's sensitive data in that state file. I maybe don't want to put it in a source control system. Now, there are backends. By default with Terraform, I'm using a local backend. That's where I'm actually storing the state, where I'm running these configurations. I can also create remote backends. So that would have a remote state. I could use an Azure storage account, for example, as a remote backend. So that could help with having a consistent state used across multiple people. Another option would be I could have a jump server, and people always run the Terraform from the jump server, and the jump server has the state file. For larger teams, I'm probably going to use Terraform Enterprise. That gives me better collaboration, governance, out-of-the-box pipeline integrations, really stronger locking to help enforce and control that concurrency. It's going to ensure the integrity of my state files. So if I'm going beyond just sort of myself and I'm working as a team, I probably want to look at a richer kind of option for that state. And again, be careful. Even when I have secrets and maybe they're stored as sensitive, they may end up and likely will end up in that state file. So you want to be careful what I do with a state file. Now, what if I do get state drift? If the infrastructure changes outside of Terraform, we need to update the state file. There is a Terraform refresh command I can use. Then there's also a Terraform import. For example, if I had existing resources and I want to manage, but just be careful with both of these. These are not really something for a beginner. So the important thing when I'm getting started is, hey, I'm using Terraform, don't use anything else. Everything I want to create, I'm going to create via Terraform. Let's look at the files in a little bit more detail. So the Terraform code is this HCL. This is the HashiCorp configuration language. This is the declarative language used in those Terraform files, and it really is documentation as code. I create these configuration files. Well, it documents the configuration as well. It's fairly easy to read. And as I showed you before, it's generally about 30% less code than if it was an ARM template. So there is less stuff. It is easier to read. Now I can do comments. There's expressions I can use. They're a little bit more advanced, but I have all of those kind of capabilities. So let's look at the anatomy of a Terraform file and the resource part of a file. Now, resources use the same format no matter what the provider. So it doesn't matter if it's Azure or AWS, it doesn't change the format of a resource. It's going to be the resource keyword, the type of the resource, the name of the resource, and then parameters. So that could be, hey, it's an Azure RM storage container, the container name, in this case container 1, and then some parameters around it. In my example file, we can see, hey, I have 2 resources. So in my resource section, I have my storage account, that's the type of the resource. I have the name of the storage account, then a number of parameters for that. Then I have a second resource that is the container. So as a complete file, I'm going to have my provider section with optional version information. So in my file, I have the provider keyword. It's using the Azure RM provider, and I want version 2.11. And I have to have this kind of features block. It can be empty, but I have to have it or it will fail. Then I'm going to have a data source section. This lets me reference existing resources. In my case here, I'm referencing the resource group that already exists. And then I have my resource section where I define these things. I then have variable files. So this is where I can define variables that I want to be able to pass in. And the goal of this is that it lets me separate anything that is environmental specific. So again, I can have a variable file for test dev and UAT and production. This is the variables.tf file. This lets me version control the main configuration file. I don't have to change it as it then moves between different environments or instances. All I would have is different variable files. These variables are declared and I can set default values. If there is no default, the user will be prompted. And I can also set variables as part of the command line, which I showed earlier. I can have a terraform.tf vars file. I can set environment variables. So I have all these different things. And in order of precedence, a command line flag will take precedence. Then something I have in a terraform.tf vars file. Then an environment variable. Then stuff that's in my default variables.tf. And then finally, I'll be prompted. So I have all these different layers. Then I have my outputs file. These are messages and data I want to be displayed post the apply. And again, the example I gave is maybe something I don't know before the application, and that will be created as part of that application. For example, hey, you're creating a public IP. Here's what that public IP is. That's going to be my outputs.tf file. Now, the Azure Resource Provider. Currently, it is at the second major version. Now, as I showed earlier, and this is the reason I start with blank environments when I demo to make sure I remember to mention things, you must have the AZ CLI installed. And then one of the big things we did with the V2 is in the past, I could accidentally import existing resources. It's something that already existed and then modify it with Terraform. Now it will not let me do that. It will force me to do a Terraform import before I can actually modify them. Now, one thing that often comes up is, well, how up to date is this? So there is a very close partnership between Microsoft and HashiCorp. There's this multi-million-dollar relationship. Microsoft has its own Terraform dev team that help manage this provider. They work closely with HashiCorp. So many features will actually be supported day one for the Terraform Azure provider. A lot of major Azure customers use Terraform. As I mentioned already, I have to import resources that already exist to be managed. And this is an official plugin. This means it's distributed by HashiCorp. I don't have to manually install it. Now, when I create Azure resources, there are a number of quick starts actually available for me. And just like ARM templates, my recommendation is go and look at these quick starts and find one close to what you want to do. So here's the quick starts page. We can see there's ones around web apps, Linux containers, AKS, using Helm with AKS, static pages, virtual machine scale sets, AKS enterprise. So you can go and look at these and notice it's got the main.tf, the variables tf. And I can go and look at, hey, this is what it's doing. There's the version. Just gives you a hint of kind of how to get started. So go and look at those templates, find one that's pretty close to what you want to do. For the more advanced authentication, to get an idea of all of the types of resources that are available, just go and look at the documentation. So if we jump over to the Azure provider, it talks through, hey, look, how I can authenticate using a managed identity, using a service principal. It will actually give me examples of using all of those types of commands. It has a list of all of the types of resources I can actually leverage and examples of their use. So the documentation here is kind of super useful. And I can also use environment variables to actually set some of these values. And it kind of talks through some of these. Hey, look, I can set an ARM_subscription ID to set the subscription I want to use. Which cloud I'm using, what's the tenant ID, certain types of secret or certificate. So you can actually pass things. I can have it as part of my profile, for example, to set these values. It could be part of an application as part of a deployment pipeline, which will then get used by Terraform. So you can take a second, look at those things. They really are kind of super useful. Now, what about interacting with Key Vault? So Azure Key Vault, I can store keys and secrets, certificates. And I use a secret typically when I have some sensitive data. I don't want it in a variable. I don't want it in a Terraform file. I don't want it in my state file. Now you have to make sure the account that Terraform is running as, be it myself, be it as that managed identity, be it as a service principal, has rights to secrets in the vault. But then I just reference the secret like anything else. It's really not special. So over here, in this same, I have a key vault, and I have my Savile vault, and I have some secrets. One of them is this kind of simple password, nothing fancy. If we go and look at it, we can actually say show the secret. It's password, nothing that great. And what I have, I'll actually close these files down for a second. I have another sample file. What I actually do is I'm going to change folder super quickly. And in this, you can see I'm using the Azure RM provider again. This time I'm looking for a variable called KV. I'm not setting it to anything. And what I'm going to do is actually show you using an environment variable to set that value. Then I'm using the data type to reference an existing Key Vault secret, i.e. sample password. And I'm passing in the Key Vault ID via this KV variable. So it's $ curly braces var.kv, because there's my variable KV. Then I'm going to use output to show you the value of that. So really pretty simple. So what I do in here is, again, I have to do an initialize. I've not done this before, but it's going to go and pull in my Azure RM provider. Then I have to do a plan. Now notice it's saying, well, I need a value. I've not set it anywhere. So I'm actually going to cancel out of that because what I forgot to do was set this environment variable. So in PowerShell, I'm just going to do $m:. Now I'm putting tf_var_. So I put that in front of it. That tells Terraform to go and look for these things. Then the name of the variable is just KV. Then I'm setting it to my ID of my key vault. My sub ID I've already got set as a different environment variable. So there I'm setting that. Now the plan should see that environment variable and use it as part of the plan. Now it's not creating any resources. It's literally just going to go and reference that existing bit of data and then output it. But I would reference it as anything else. If I did have resources that I wanted to use that password, maybe I'm creating a VM and that's local admin password, or I'm joining the domain, I would just reference that $var.kv. So now if I run the apply, it should, my output, spit out the secret. I don't have to actually change the key vault to say, hey, allow ARM templates. If I'm using a secret through an Azure ARM template, I have to set the vault to allow ARM template interaction. I don't have to do that for the Terraform. It's just going in via the regular API. So it's going, it's checking the state, and it should spit out that password. Really just showing me how easy. And there we go. A secret from Key Vault. There's my password. So that's how I can interact with Key Vault. Again, whatever security principle Terraform's running as would have to have rights via the policy on that Key Vault to the secrets. A few other useful components. Now, obviously, in Azure, I can use extensions. I can use the run command, custom script extensions, lots of other things. There's also a file provisioner that's part of Terraform that can be useful to copy a couple of files into a remote machine. There's also a remote exec provisioner to trigger commands on a remote machine. This is for maybe just doing a couple of things, but again, I could use the Azure specific extensions to do this as well. If it was more complex, I'd probably use something like PowerShell DSE, Chef, Puppet, Ansible, etc. Pipelines. Hopefully you're not just manually running these like I am. So in the best case scenario, I'm checking my code in somewhere. I have pipelines to actually do provisioning of the infrastructure of my application. There is a marketplace extension for Azure DevOps that adds Terraform tasks to my pipelines. And there is also a HashiCorp setup Terraform GitHub action. What that does is it actually adds Terraform to the path of GitHub actions. So then all of the regular commands I can trigger as part of a GitHub actions pipeline. So I can do the apply, init, plan, etc., etc. So it's very easy to integrate Terraform with your pipelines. Finally, if there was a scenario where, hey, look, I have this feature I want to use, maybe Terraform provider doesn't support it yet, or I just have a ton of ARM templates, I don't want to recreate them all. Yes, I can call an ARM template from Terraform, but it is discouraged. Remember, HashiCorp work very closely with Microsoft to ensure the Azure provider for Terraform is up to date. There shouldn't really be many things that I can't do natively with Terraform. Because the downside is, yes, there is this Azure RM template deployment. This lets me take an ARM JSON and push it with Terraform. But Terraform is not aware of the resources that are being pushed through that template. If I was to destroy, for example, it wouldn't delete the resources. It's just going to delete the reference to the template. So I really want to try and make sure I have kind of native Terraform objects. But if I'm absolutely stuck, then yes, technically I can call an ARM file from Terraform. As I mentioned, the code that I showed here is in my random stuff GitHub repository. If you go and look in my Terraform with Azure, I've got those basic files. And I've also got kind of referencing that secret. And just something maybe useful for you, I've kind of got my git ignore file as well. Because one of the things you probably don't want to do if there was sensitive information is, for example, send your TF state into a repository. I also don't want to upload the plugins. So my git ignore file is kind of ignoring all of the .terraform content, ignoring any state files. And if I created kind of a plan, I use plan out. So I don't want to upload that either. So that just may be useful if you want to go and look at the code kind of I've used here. So I hope that was useful. If it was, please kind of like, comment, subscribe. And until next time, take care.